We're going to look at 6.1 notes, which is finding the area between two curves. We're actually going to split this into 2 days. We're going to do this with respect to x and with respect to y. So far we have been doing integration, and we know that an integral is actually standing for, when we look at our f of x, and we want to look at an interval from a to b, this integral is actually equal to that area under the curve to the x-axis. So if our answer turns out to be positive, we know that area was above the x-axis. If it's negative, we know that area was below the x-axis. Well, now we might want to find the area between two curves. So if we're looking at just this area between f and g, so far if we do the integral going from a to b, and let's just put a here, and let's put b here. If I find the area of this guy right here, that's going to give me this area all the way down to the x-axis. Not to g, but to the x-axis. Okay? Well, if I do the same thing for my g of x, I do that integral from a to b of g of x, that is going to give me the area under g of x all the way to the x-axis. So if I want to find the area in between these two curves, what would you suggest we do? Well, what we will do is we will subtract them, because that will give us the area that is in between. Okay? Now, to make sure that we are going to get that area, and I want you to think about, we are going to carpet this area that's in between these curves. So we want that area to be positive. In order to make sure that this area is positive, the function that goes first, that f of x, has to be the top function. The g of x, that's going to be the bottom function. Your integral limits are going to be that limit from the left and that limit from the right. Okay? Making sure that that right limit is on top, because that is the biggest number. Okay, or the bigger number. Let's not put positive there. Bigger. And then this is our smaller. This will ensure that our final area is going to be positive. In order to make sure that we've got the right top function, the right bottom function, the right left, the right, we want to make sure that we are graphing these. So to find the area between two curves, number one, you are going to graph both curves. You need to see which one's the top function, which one has the higher y values. Okay, step 2, if an integral isn't given, then we're going to have to find out where those two intersect each other. Okay, because we need to find out that left endpoint, that right endpoint. Then you want to set up your integral. Whether you get to use your calculator to integrate or you have to integrate on your own, you're going to have to write that integral. And then, of course, integrate either by hand or with your calculator. Okay, so let's look at our first example. We want to find the area that's bounded between y equals square root of x, which I have here, and our line y equals negative 1/4 x, and we want to go in between 0 and 4. Well, they happen to intersect at 0, and then 4, we're chopping it right here. So we are just looking at this area right in here. So when I look at that area, I know that I'm going to set up my area equals. Now my left endpoint is 0, my right endpoint is 4, so 0 to 4. My function that's on top is my square root of x, so square root of x, minus the function that's on the bottom, so minus a negative 1/4 x, and make sure that you do change that, and then make sure you put your dx. So if you're going to use your calculator on this, it doesn't matter to me if you're going to use your calculator, you're going to use your brain power. I am, of course, going to make you do both. You have to write this statement out. Okay? So if we do want to use our calculator to find this integral, remember you're going to actually type in your y equals as the square root of x plus 1/4 x, and then you're going to integrate that going from 0 to 4. That turns out to be 22 thirds. Okay. Now, if you integrated by hand, of course, you would do your x to the 3 halves divided by 3 halves, which is multiplying by 2/3, plus, and then 1/4 times x to the 2nd over 2, and then you would put in your 4 first and your 0 second using your first fundamental theorem of calculus, and you're still going to get your 22/3. Now, if you come up with an answer that turns out to be negative, that means you chose the top function incorrectly. They're actually switched. So if you get a negative area, go back and check your setup. Okay? Let's look at our next example. Finding the area bounded by x to the 3rd minus 4x. Y equals 0, so that's this guy right here, and 0 for x and 2 for x. Well, that just so happens to be where it does intersect the x-axis, so we are looking for this area that lies between them. I know you're looking at the wicked graphics going, woo, I want to be like Miss Summers. Look at her go. I know, and I don't know why I have to shade it in. Okay, focus. Here we go. So I'm looking for this area right here. We know that this function, x cubed minus 4x, it continues on, but once again, they are zeroing us in on just that interval. So when I go to find the area, I am going to put A equals for area. From left to right, we're going as far as 0 to 2. And then the top function is that 0. Okay, that top function is that y equals 0. So I'm just going to put 0 and then minus my bottom function. And I'm going to put that in parentheses to make sure that I distribute that negative through correctly. So top function minus bottom function. Of course, if I was going to integrate this by hand, I would clean this up, simplify a little bit along the way. Okay. But I'm just going to plug this into my calculator and find out that my answer is 4. Remember, if it turns out to be a negative area, you've got them switched and you need to fix it. It's not enough to fix your answer, you have to fix the whole thing. In an AP test, they're going to grade you on your setup and the answer. And in fact, most of the time your setup is going to be worth more than your answer. So make sure your integral is correct and you have that answer. And you also let them know what you're finding. That's the area. Now on this example and the example before, they actually told us what our A and B were going to equal, but that is not always the case. In fact, that's very rarely the case. What they're going to do is they're going to give you those equations, and there may be more than 2. We're going to do examples where there may be more than 2. And they're just going to ask us to flat out find the total area that is bounded by those 2. So what we need to do, we still need to graph them. Y equals x squared, that's the green guy. Y equals x plus 6, that's our blue guy. And notice I just have a quick little sketch. I don't have it perfect by any means. Not that even if I picked points, I could make it perfect. But I just want to make a little sketch so I can figure out how many points of intersection I'm looking at, where, which function's on top, which function's on the bottom. Well, it looks like that line's on top, the parabola's on the bottom. I need to find out where they intersect. We can use our calculator and put y1 equals x plus 6, y2 equals x squared, and then use our intersect function on our calculator. But remember, we don't always get to use our calculator. So the other way to old school find our points of intersection is to set them equal to each other. And then factor. Okay? If they don't let you use your calculator on the test, they are going to make them factorable most of the time. So when I go to that and I factor it, I find that x equals 3 and negative 2. So negative 2 to positive 3. I have my endpoints. I know which function's on top, which function's on the bottom. I'm ready to go. I set up my integral. I always want to put what that equals. We will be finding volume as well, so it's going to be important for you to show this is area, I know what that represents. V, this is volume, I know what that represents. Once again, make sure you write this integral out. If you get to use your calculator, you'll get right to your 34/3. If you don't get to use your calculator, then you will integrate, like I've shown you. X squared over 2 plus 6x minus x to the 3rd over 3. First fundamental theorem of calculus, put 3 in for all your x's, minus, then put negative 2 in for all your x's. If you don't get to use your calculator, please be careful of your algebra. Make sure negatives and so forth are being taken into consideration. So my answer, my total area, would be 34 thirds. Okay? Now you might be thinking, now why do we need to find the area in between two curves? Well, in the real world, if you're looking at functions, I want you to think about maybe this top function as being your revenue function, the green one as being your cost function. So all that goodie in the middle, in between your revenue and your cost, that's your profit. When your revenue is on top, your cost is on the bottom, you are making profit, you're making money. Ooh, if we were to look over here and over here, when the cost is on top, ooh, that's when we're not making a profit. So there are many, many instances where we will be finding the area between two specific curves. Profit is just an example of one of them. All right, so let's look at another example. Find the area bounded by, and I did do my graph just a little bit more accurate than the other sketch you just saw, but that's just because I'm finding my intersection points, and I kind of wanted to give you an idea of what it would look like on the calculator without switching to the calculator. I will be doing that in a slide, and you'll see how effortlessly, it goes. But anyway, so I want to graph both of these functions. We know this is a parabola pointing down, and I know the y-intercept is at 1. I know this guy is a line. Ooh, his y-intercept is 1. So already we know one of those points of intersection. Now, they both have the y-intercept of 1, but look at this. This is in terms of x. So when I find that area, these need to be x's. Right in there. So when I find those points of intersection, I'm looking for my x coordinate. So if I set these guys equal to each other and I factor, so you're just doing negative x squared plus 4x plus 1 equals x plus 1. We want to get those all to the same side, so we would add our x squared over. We would subtract 4x, so that's going to be negative 3x, and then we would subtract our 1 over. So we're looking at our intersection points. Factor out that x minus 3. So we're looking at x equals 0 and 3. Okay, so 0 and 3. The function that's on top is my parabola, and the function on the bottom is my line. If you are going to integrate this by hand, then please make sure you simplify this all nice and pretty. If you're going to go ahead and use your calculator, you'll find your answer immediately. So if you're just putting it in your calculator, you're going to get 9/2. If you're going old school and you're solving this without a calculator, you are going to simplify this integral. So you would have negative x squared plus 3x. And then when you integrate that, you'll have negative x to the third over 3 plus 3x squared over 2. You're going to put 3 in and then 0, and you're going to get the same answer. Okay? But if you're going to use your calculator, go ahead and use your calculator. You do not have to simplify it. But if you're not using your calculator, simplify first, please. Okay. Now in our next slide, it says find the total area bounded by y equals x cubed minus 4x and y equals 0. Now it does say total area, but there's no guarantee. It may just ask you for the area bounded by those two. I want you to always think total. Well, like I said, I'm going to show it on the calculator. Help us all. Okay, so if I'm looking at my calculator, and I have zoomed in here, I've got this graphed, and remember you're looking at the y equals 0, so you've got two areas. You've got the area over here above the x-axis, and you've got this area below the x-axis. So when I'm looking at this, if I just kind of quickly make a little sketch here, I have area 1 and area 2. So this is going to be our area 1. Let's make that blue. And then I've got area 2. Let's make that purple. We do have to find those points of intersection. You can set that equal to 0 and then find where it intersects the y equals 0. It happens to be at -2, 0, and +2. And you can use your calculator to find that out, or just set them equal to each other and factor. So when I'm finding the area bounded by these two, I am going to have to do two different integrals. So this first one, I'm going from -2 to 0. Make sure this is the left endpoint to the right endpoint. The top function is my cube. The bottom function is my 0. Then I'm going to go ahead and set up the area 2. This is going from 0 to +2. This time the 0 is on top, that line y equals 0, and then I have this guy. If you don't want to use the parentheses, then go ahead and distribute that on your own. Now, these guys are symmetric. They're symmetrical with respect to the origin, so whatever you get for area 1, you should get for area 2. Always, always remember that you can use all of your knowledge to help you reach the conclusion faster. They're symmetric, those areas should be the same, but you still have to show your work. When they ask for total area, I'm going to take A1 plus A2. That gives us 8. Okay? So 8 is going to be our final answer. Now I want to look at this guy here. We're finding the total area bounded. Well, now it says total area on this one too, but when I look at the picture, I'm noticing really there's only this area right in here. Now remember, we're going to the x-axis, so it stops right there. Now this one's a little different. I do have two areas. And I know you're thinking, but wait a minute, the last one I could see the two areas. I had this area over here, I had this area on the right side, I could see two separate areas. Well, now on number 9, or on slide 9, when I'm looking at this area, I do have two different areas. Now let me blow this little piece up. This piece looks like this. Oh my heavens, this artwork is fabuloso. So this is what it looks like. Looks like a shark fin. Now what we mean by two different areas, I want you to look at this. Okay. So when I look at that, remember I am writing integrals according to the top function and the bottom function. Well, when I look at area 1 here, my top function is the parabola, or is the square root. The bottom function is the line. Okay, so I have square root and I have line. In area 2, my top function is that square root, but the bottom function is that y equals 0 line. So the top function and the bottom function are not the same throughout the whole entire shaded area. So that means I have to split this up into two separate areas. So area 1 and area 2. Whoa. There we go. Okay. So we'll need to find all those points of intersection. We'll need to find this point where this diagonal line and the square root, where those intersect each other, where the diagonal line intersects the x-axis, and where the square root intersects the x-axis. So that's going to be at -2, that's at 0, that's at +2. I'm ready to go. So from -2 to 0, the square root's on top. and you are subtracting that diagonal line. So I'm subtracting a negative x. Area 2, I'm going from that square root. So I'm going from 0 to 2, that square root, and then I'm subtracting the y equals 0 line. Now if you don't want to put the minus 0, you don't have to. These don't come out to be nice and pretty. When I put this first one in my calculator, I get 1.44777153. Remember, our final answer has to be accurate to 3 decimal places, so don't just take it out to 3 decimal places, take it out further. You may only round 1 time per problem. So this area was 1.8856562. So the total area, you're going to add those two together, and then you may round to 3 decimal places. So 3.333. So when they talk about when they talk about total area, always look at that shaded interval and check out, does your top function and your bottom function stay the same throughout your entire shaded area? This time it was no. On slide 8, this was a little easier to see because you saw 2 separate distinct areas. Okay? So be careful, this guy is sneaky. Is your top function the same as the bottom function all the way through? Okay? Okay, so you've got a little review problem to do. We'll do that one in class tomorrow. Your next video, 6.1, day 2.